Hello and welcome to IoT World Today. I'm Lauren Horowitz, Senior Content Director at IoT World Today. And today we'd like to sit down and talk with an expert about the future of transportation. I'm speaking with Steve Griffith, who's Industry Director at the National Electrical Manufacturers Association. And we're going to talk today a little bit about some future trends and sort of tease some of his content that he'll be presenting at the Industrial IoT World show. So Steve, I'm going to start by asking about artificial intelligence, which is a very well-hyped topic. So let's talk a little bit about how AI can address connectivity and communications for critical transportation infrastructure and smart city environments.
Great. Thanks, Lauren. Happy to be participating in this interview. So I think I agree with you. Artificial intelligence is an emerging technology that's becoming more and more relevant when you're looking at it with transportation infrastructure. And there are actually a number of cases already being put in place where we're seeing AI address connectivity and communications. I mean, I could give you some examples. For example, adding AI to streetlights. Streetlights can be equipped with an array of sensors to monitor traffic flow, send signals to traffic lights and other traffic control devices. If you're equipping these cameras with the connected vehicle technology, streetlights can enable like license plate recognition of cars that go by. Another place where we're seeing AI in connectivity is how AI addresses congestion, which is obviously a big issue in smart cities. Taking that predictive and data-driven approach to traffic signals. Sensors are everywhere on the roads, right? So these can collect real-time traffic data, car counts, areas of congestion, accidents, road hazards, like a fallen tree, floods, and the data can be sent to the cloud or processed in an edge server to provide, prediction models that, based on the time of day, the weather, the temperature, the incident occurrence, and that, these models can be used by agencies to kind of plan the most effective traffic flow in a smart city. And then, looking at sensors on roads, parking meters, or other fixed places that can monitor parking spaces. You can identify whether spots are free or occupied and create real-time parking maps. So when you're looking in it, trying to find a parking spot in the city, you can see which spaces are open. Parking managers can monitor usage for each spot, determine most optimum locations if they need to expand spots. So there's a lot of, I think, examples where I'm seeing AI already, tackling this big issue with connectivity and communications and getting all that data and putting it to good use in smart city and critical transportation infrastructure.
So my next question is sort of a follow-up. I mean, there's a lot of sort of real-time data ingestion and processing happening either, as you mentioned, at the edge or being sent back to the cloud that puts a burden on the network. So can you talk a little bit about the role of connectivity as we move forward? What does the network look like? What are some of the connectivity options? How do you foresee this playing out?
Yeah, that's a great question. And and our members manufacture these devices, and they're bringing connectivity, right? Whether it's a device that's going in a building, across the utility or infrastructure. I mean, so all this data, and then you're going to see a lot more, wired and wireless networks playing a major role. I mean, they've got to be fast, they've got to be reliable, and they've got to transmit data. And I think you're going to see a lot of them started to be incorporated together. I mean, you already have 4G, LTE, you got Wi-Fi, but I think we all talk about 5G, and I think that's where we're starting to see it could be a huge kind of game changer with connectivity in the smart cities, because we're already seeing it across our members, right? For like in buildings, you've got to have 5G to address all the wireless backhaul connections for data throughput. And in lighting, you're integrating all these sensors, all these networks, and then increased demand for connected lighting controls, emergency lighting. If you're looking at the utility products, there's smart G connected microgrids, that combine intelligent AI with conventional systems, right? Um, the need for more smart meters and intelligent capacitor solutions. And finally, looking at transportation, 5G into enabling intelligent transportation systems. Huge demand for data processing capabilities in the car and the network infrastructure, more powerful chipsets and processors. Interoperability is going to be key between LTE, V2X. You're going to need chipsets that support multiple types of communication technologies. So I think, and 5G is coming, and I think that's going to kind of change how we rethink connectivity in that smart city scenario.
So when we talk about transportation, we talk about autonomous vehicles. Obviously, security is a huge component of the discussion. Can you talk a little bit about where things are at in terms of security and transportation?
Security, yeah, it's a good question. I mean, as the vehicles become autonomous and connected, you're increasing all your attack points, right? Bad actors can get in through Wi-Fi networks and hardline connections to exploit, aspects of a connected car. So, I mean, kind of looking back from how we address it from the infrastructure perspective, we always believe that the best practice is to build cybersecurity in from the inception, built in, not bolted on, right? And if you look at the infrastructure piece, that there's some things that I think the infrastructure can things that we do in infrastructure to secure it can be applied to the vehicle. I mean, for example, within NEMA, we talk about cybersecurity quite a bit, and we look at the supply chain, which is, all the components that would go into a vehicle, and how do you, as you're in the supply chain, how do you look at minimizing the risk in that, so that when a product gets deployed into its end use environment, there's no way that malware can take over. So it's looking at your embedded components, trying to analyze your anomalies there. It's tamper proofing to make sure you can't alter a product or a system from the production line to where it's the operating environment. It's how does that device, when it's deployed, comply with the requirements, and then lastly, if you're pulling a device or decommissioning a device, it can't be used as a means to penetrate an active network. So I think there's things that the infrastructure is doing that you can take it and apply it to the vehicle itself. A lot of good practices and even a lot of industry standards out there that can help address and mitigate cybersecurity. I mean, there's no silver bullet, but I think there's things you can do to mitigate those risks for cybersecurity and connected vehicles.
So next, I want to ask you a little bit, when we talk about security, we often talk about sort of the various standards that have entered this space. Can you talk about the importance of smart connected transportation infrastructure, industry lead standards?
Yeah.
And where we are with that?
Yeah. No, and I think you mentioned, V2I communication. That's the communication of data between vehicles and infrastructure. A connected vehicle that moves through a suitably equipped intersection can share information about crashes, traffic jams, sharp curves ahead. Our member companies that manufacture the intelligent roadside equipment are already hard at work, because NEMA is a standards organization. We have a pretty large stake in the deployment of roadway safety technologies, including V2I type functions that contribute to the reduction of roadway accidents through the deployment of connected vehicle infrastructure. So we've actually been doing a lot of work over the last year in developing a harmonized standard for roadside equipment that basically treats the communication technology, whether it's 5G or DSRC, as technology agnostic. It functions on the practical user needs for a roadside unit, like emergency vehicle signal preemption, right? You can preempt signals so an emergency vehicle can get to its destination quicker. Red light violation ahead, pedestrian crossing, entering a school or work zone. So this NEMA standard, NEMA TS10, which is an industry-led standard by the private sector, is basically designed to provide practical user needs for connected vehicle infrastructure, roadside equipment that could communicate with the vehicle to, transmit basic safety messages in a common format. Doesn't matter what, it doesn't matter what the technology is. So you talk about the importance of industry-led standards and their harmonized standards, right? So we all know that connected vehicles and connected vehicle infrastructure have that potential to save lives, right? So we're trying it from the infrastructure perspective to promote deployment of infrastructure that can talk to whatever kind of vehicle is on the road, right? Whether it's a Ford or a Toyota or a GM. So it's a big thing of what we do here at NEMA. So.
And very important. And finally, let me ask this. None of us have a crystal ball, but some of what we've talked about is sort of requires future build out. Talk about, is it 18 months? Is it 3 years? Talk about that.
Building out, yeah, and there's a lot of opinions about the smart city concept. There are a lot of pilot locations in the U.S. that are looking at smart cities. I think Columbus was one, and I know there's different pockets. I think you're going to see a lot more of these regional case studies. These regional locations adopting these technologies, right? You'll see that incrementally, right? And as I think no one can pick their future, but I think cars are going to get more smarter. They're going to get more digitalized, right? So this data tsunami is going to continue, right? And you'll see it, I think, in certain locations throughout the U.S. You'll start to see more of this concept take hold. I mean, there's probably places in California, they're doing a lot of testing with autonomous vehicles, and Arizona. So I think it's going to start to pop up more often as we move forward in the next 5 to 10 years. You'll start to see a lot more of these pilot programs throughout North America. But we've got a long way to go, but I think we're moving in the right direction.
Right. Something we'll sort of see roll out incrementally over these next 5 to 10 years.
Yeah.
Well, Steve, I want to thank you so much for joining us today and talking about some of these core issues as we look to the future. So thank you. And for our listeners and viewers, for more on all of these topics, you can always check out IoT World Today. And you can also register for the Industrial IoT World event in December. And we'll have the link included below this video. So thanks so much for watching. And until next time.